All right, so in 7.3, starting to take our knowledge of spreadsheets and make them more visually appealing, right? Starting to talk about turning our data into different graphs and charts. So as you can imagine, all these tables of data and sorting out your information is nice. It can be organized, but it's not always the best idea to just present a whole table of data. So we'll start kind of by saying somewhat of the obvious, I guess, representing data as a chart or graph can be more visually appealing and oftentimes easier to present than just I don't know, a range of raw data, right? I could have a whole table of information, but if I'm trying to present um, the data or make a clear point, it's really hard to do that with just the whole table of raw data. Sometimes it's easier to summarize my information into a graph. We're going to focus on 4 types of charts that we can make in a spreadsheet. This is where some of the nuts and bolts might differ between programs. And by programs, I mean things like Excel, Google Sheets, or Numbers, which is the Apple equivalent. Um, so kind of the nuts and bolts are a little bit different, perhaps, between programs. I'm not, as for something like Excel, I haven't used in a while to remember how different, if at all, it is. But just be aware that if you go from Sheets to Numbers to Excel, with this section specifically, things might vary just a little bit. I'm, of course, going to focus or model based on Google Sheets because we've been using the Google Suite in our distance learning, so that's where all your assignments are. So we're going to focus on 4 types of charts, and the first one that we're going to talk about is a bar graph or a bar chart. And something that I'll just see if I can leave that, there we go. Something that you might want to make a note of in Sheets is that Sheets draws a split, a divide between 2 types of bar charts. So we'll say that Sheets denotes, say, column for a vertical bar chart, and bar, for a horizontal, oh, sorry, that's backwards. For a column, nope, wait. Nope, I'm going crazy. Column is vertical, bar is horizontal. Bar for a horizontal bar chart. So Sheets denotes column chart for a vertical bar chart and a traditional bar chart for a horizontal bar chart. So maybe a little backwards than you're used to, but realistically either is fine. Our brains are more used to seeing vertical bar charts, but either is okay. So when are we going to use a bar chart? A bar chart is best for organizing data that has been sorted by category. So maybe I'm looking for maybe demographics. I just want to know how many freshmen there are at the school, sophomores, juniors, seniors. I want to know maybe how many students from each town I have. You never know, right? It's just something that you're kind of categorizing, right? You're not really looking for any sort of trend over time. You're just comparing between categories. So I'll show you how all of these work in a little bit. Let's just kind of start by talking about the different types of graphs that we're going to deal with. So the next one that that we might talk about is a line chart or a line graph. And this is the one that you may be more familiar with as well. This is best for analyzing trends. Analyzing trends over time. Let me fix that. There's really no other use for it. If you're going to draw a line chart, you're trying to look for some sort of change from, maybe in the last 10 years that you've run your business. So you look at the stock market is the perfect example of a line chart, where they're showing trends even like minute by minute, hour by hour. So you're showing a trend of a stock over time. And then we're familiar with a pie chart. Oops, a pie chart. And a pie chart is best for showing how a category is part, or I'll say makes up part of a larger whole. Of course, the whole circle, the whole pie, our percentages must add up to 100%. We've seen this before where with my pie chart, maybe the wedges don't show percents or the wedges don't add up to 100%. This would be a poor example of a pie chart. So usually I want to show parts of a whole. This is usually good for maybe demographics, right? Maybe I want to see how many males or females I have in a population. Or I want to say out of the whole student body, what percent is of the class are freshmen. The last one I want to talk about is one we've been talking about all year, and that's a scatter plot, or Google Sheets will call it a scatter chart, but it all means the same thing. So just like we've talked about since pretty much day one, right, a scatter plot is best for comparing two sets of data and looking for a trend overall. Remember that these are disconnected points. We've talked about things that associate with scatter plots like linear regression and correlation. Note I want to make on that is that in Sheets, if we talk about correlation, they're just going to talk about R squared. It's really no different than R, except I'll say this. We'll say R squared serves the same purpose as R, but only indicates strength. Obviously, again, just the closer to 1, the stronger the correlation, or the better the model fits the data. Again, things we already know, things we've already learned. So kind of just my 4 different types of graphs here. So let's kind of go through and talk about how to do these all on Google Sheets. The first one I'm going to start with is my bar graph. A lot of the beginnings of this is going to work the same, right? To get anywhere with this, I'm going to highlight the range of cells that I'm interested in working with. So I'm going to highlight the range of cells that I'm interested in working with. So in this case, I care about my headers too, because what Google will do is actually automatically label your axes, and I care about the actual data, right? I care that Gina Raimondo got 200,000 votes and so on. So I'm going to go to Insert, and I'm going to go to Chart. They like to default give you some sort of a suggestion, but right now I care about a bar chart. You can see that they actually give you some suggestions here, which is nice. Sometimes they're right. Sometimes they're helpful, sometimes they're not. We'll stick with my normal vertical bar chart, or they like to call it column chart. So I'm just going to click on it, and I'm just going to shrink this so it fits on in my window here. There we go. You can see that it automatically scales, right? We automatically scale. So let me just kind of catch up with my notes here. We highlighted, take notes here. We highlighted, whatever it is, we highlighted our range of cells, range of data. We clicked Insert, and then clicked Chart. We can select our type of chart. So I want a column chart or a vertical bar chart. Notice a lot of things here. We notice that Google has suggested a title. We notice that they've already labeled our axes, and we notice that they've already picked an appropriate scale for the graph. We can change all these things if we wanted to. You can see they kind of gave you some options down here. If I wanted to actually use column A as a table, sorry, as my labels, or row 1 as my headers, which I am actually. If for some reason I didn't, right, Google's kind of going off of what they think is going on with the data, but I could change these, and you see that my data adjust accordingly. But in this case, Google's AI actually got this correct, so we don't really need to change much. If I want to go to customize, though, I can change a whole bunch of things, right? I can click chart style and change my colors. I can put it in 3D if I wanted to. If I did chart and axis titles, maybe I want to change my titles. So maybe instead of calling this whole chart votes versus candidate, maybe I want to call it, this is actually data from the 2018 Rhode Island governor's race, say gubernatorial election results. So I can change my title to be more accurate. I can change the style of that, and I can do this if I really wanted to. I can change the color of my bars if I really felt like it. In this case, there is no, we don't need a trend line. It doesn't make sense. We'll come back to that later. If I wanted to label the actual number of votes that each candidate got, I could. This is what the data label button is for. Again, I can check my fonts and size and position, right? I could center them, or I can put them outside, or whatever I want to do. A lot of this that I'm going through pretty quickly is really kind of just for you to play around with, right? If I want to play around with whatever I kind of feel like, I can go ahead and do that. This is meant to just be a really quick overview. A legend, if for some reason I need to, maybe I'm comparing multiple bars within, so maybe I want to compare votes in different cities or different counties, I could. I could do that. I'm not going to change it here right now, but if I needed a legend, I could include one. And in this case, I don't, so none is fine. I can choose to change, actually this is just going to change my axes, or I can angle my labels if I really wanted to be fancy. I can change the text color. You get the idea. Same thing with the vertical axis. Same thing with the grid lines. Or I can choose if I wanted to choose how many steps I have in my scale. Notice how this pushes everything up or down. All right, I like to just stick with auto, so that way it just does it for me. I can change my spacing in between if I really feel like that. I don't think it's really necessary for this, but you have all these different things that you can play with. So kind of just, that was a real quick overview of this chart editor window. All right, so here's my bar chart. Right, there's my bar chart. I can do this with a pie chart too. As you remember, insert chart, they actually suggested a pie chart when we first did this. So again, let me shrink this so it fits in my window. And I can play with all the same things I wanted to. If for some reason I needed to change the row or column that I'm using as a header, I can. I can mess with my layout. I can make it 3D if I felt like it. Right? I can put a hole in the middle of my graph if I wanted to. You kind of get the idea. If I wanted to color code, so maybe I wanted to color code by the candidate's party, which actually, fortunately, in this case it did, right? Raimondo Democrat, Fung Republican. I could, if I wanted to be misleading, I could also very easily switch the colors. All the things that we've talked about before all coming back into play here. I can choose to kind of pop this out if I wanted to emphasize it. So all these things, again, I can play with. If I wanted to change my title again so that it actually reflects what I'm talking about, I can. Tutorial. I'm going to get this right. Gubernatorial election results and updates. I can mess with whatever I need to. If I need a legend, I can include a legend, and actually for a pie chart, I should. I do like what Google does on Auto, where they actually just draw a segment out, labeling it and showing the percent. But if you wanted to maybe just show the colors and not the percents, you could. If you wanted to kind of do whatever you want here. I like it labeled just because it's transparent in the sense that you can see what the data is actually saying. So there's my bar and pie chart. You can start to see that a lot of what we're talking about with all this is the same for every graph that we talk about. So with my line chart, so in my example here, we're talking about the change in students enrolled in Providence Public Schools over 10 years. But the process is the same. I'm still going to highlight the chart I want. I'm going to insert chart. And this is maybe where I'd consider playing with it a little bit because I want to actually show this change. We've talked about this before. I want to be careful when I change the scale of my y-axis because right now it looks like enrollment's pretty steady, right? It's pretty consistent. But if I wanted to show how dramatic this was, I can go to vertical axis and show a dramatic change and say, well, and maybe if I was doing this honestly, just to say, well, let's kind of zoom in on this. I want to go from 22,000, where all the data lies, to 25,000. Right, so maybe I want to show that trend a little bit more clearly. If you do something like this and change the scale, you break the axis, you should acknowledge it somewhere. Right? We talked about unfair or misleading graphs. This is where you start to run into that issue with a misleading graph. I, by the way, also like to see if I can figure this out. Oops. I tend to like to try to do this by step, by just one at a time instead of counting by twos. But I can't remember how to fix it. What does this do? Nope. So if you're able to change it. It's not the end of the world. That's just a personal preference. So the biggest thing with the line chart is if you decide you kind of need to zoom in on a set of data, zoom in where the data is, that's what this vertical axis scale is for. But definitely remember what we talked about way back, I think it was in chapter 5, about misleading statistics and about what happens when I zoom in like this. What does it do in the narrative that I'm trying to tell? Last one's the scatter plot. I tried to do something with the weather, but I couldn't access the data, so here's some hockey stats. And maybe what I'm trying to do is I'm a researcher and I'm trying to figure out if there's a correlation between the number of wins a team has and the number of saves their goalie makes in the same season. So, just as before, let me highlight the data I care about. I'm being careful, though, to highlight just the data that I care about. Right? This isn't really important in the graph, in the grid. This is just important organizationally. These are the numbers that I care about. So I'm going to insert chart. It gives me some kind of a wacky line graph. This is obviously not what I want. So a scatter plot would be more helpful. Here it is. And same thing as before, I could change everything I feel like changing. But what's important with a scatter plot is if I go to series, on my scatter plot, and maybe I feel like changing the points, the colors around. Anyway, if I want to add my regression line, I'm going to click trend line. And you see that it automatically shows up. So let me actually write this in here. So we're going to show my regression line by checking trend line under series. And you can see it shows right up, and if I want to show it with the equation, I even can. It usually does show up. So I got a linear. There it is. So I go to label, use equation, and it pops up, right? You can assume there's a y equals here. Here's my linear regression equation. Well, how good of an equation is this? The data is pretty scattered. I don't think there's much of a correlation. Well, let's check our r squared, 0.079. It's clearly a very poor correlation, right? It's very close to 0, not very close to 1. One thing that's great about this is I don't really need to know how to calculate these other forms of regression. I can just have Google do it for me to see if I come up with anything stronger. And the thing I'd be looking for with a stronger correlation is a higher R. So let's just kind of play around. All right, you can see the equations changing, but you don't really see R doing much. So we'll just kind of stick with this one. But this is, saves us a lot of time. If I want to really quickly show a scatter plot, show a trend line, it just does it right away for me. If I'm a statistical researcher and I want to show my correlation coefficient so I can use it to draw conclusions, it shows it right for me. And it's one of the great things about doing this on spreadsheet software. It saves us a lot of time, as you can see. And all these same tabs are the same as before. So this is where especially, this especially is where a spreadsheet saves us a lot of time. A lot of time. The one big tip I have is to be, I'm going to leave this whole thing in bold, be conscious of, we'll say, instances where you may accidentally or deliberately, maybe you're deliberately skewing the data, skewing the presentation of your data to be misleading. This goes back to everything we've talked about earlier in the year when we talked about ways that we use statistics to be misleading. When we talked about the line chart, right? If I really wanted to be dramatic, I could even extend this farther. I was trying to be kind of nice when I could, to still preserve the fact that this is not a dramatic change in enrollment. But if I really wanted to be dramatic, I could say maybe 23,200 to probably 24,200. Oops. 24,200. And I can show a really, I could even get rid of the labels if I wanted to, I'm sure. I could be more dramatic if I want to say, well, look at the, we shot up in students, but we're on the decline. So really be careful of instances where you might find that your data is becoming misleading, and ways that you can be conscious of that, ways that you can kind of preserve the integrity of your data.